Hey guys, go ahead and get out your notes sheet.
Alright, so slope-intercept form is the equation y equals mx plus b, and what you need to know from here is which variable represents your slope and which one's your y-intercept. And the nice thing is it's called slope-intercept form, so the first variable m represents your slope, and the second variable b represents your y-intercept. The x and y would just be coordinates that would be along the line as ordered pairs, and what you could do with those is plug them in and check later when we start solving these. But we have looked at how to find slope already, so you should be good with that. And then your y-intercept, we talked about how to find it from a graph. We're going to look at how to find it as well when you have equations and not necessarily the graph. Something important to note is that in order to use slope-intercept form, equations must be solved for y, and that is literally because the equation is in a y equals format, so you have to have y by itself to identify your slope and y-intercept. So these equations are on your note sheet, and what we're going to look at for these examples is how to identify your slope and your y-intercept. So you would technically, again, need to have it in a y equals format, and then once you do, something I normally tell people is, well, write out y equals mx plus b, and then literally just look at the place of m in the equation and understand that the coefficient of x will always be your m, which is your slope. So in this first example, it's -4, and b is the constant that would be all by itself, so that'd be 12. Second example, so if I write out y equals mx plus b, and this one's just a little backwards because of that symmetric property, the variable m is always in front of x, so that's your slope, 1/2. And then your y-intercept is that coefficient all by itself. Now in this one, it's not just 10, it's -10, so it's important to keep the sign in front of a number as well. Okay, so these two examples are where you would actually have to solve for y before you can list your slope and your y-intercept. So why don't you guys go ahead and pause the video and practice solving for y, and then we'll take a look at what your slope and your y-intercept are. Whenever you're ready, you can just press play and check what you got. Okay, so for example 3, to solve for y, you should have first subtracted your 1x and then divided by 3. So you should have had that -1/3 x minus 4 and solved for y. So as we go to identify m and b, m is again your coefficient, which here is -1/3, and b is not just the 4 again, it's the -4, keeping that sign in front of your constant. Example 4, to solve for y, you should have subtracted 3x and then divided by -2, and because you were doing -3 divided by -2, you can actually simplify your coefficient to +3/2, so m should be +3/2, and then b is your constant, which should have been that +7. So hopefully that makes sense. It's pretty easy. It's really just solving for y and identifying what's in place of m and what's in place of b for your two values. Okay, I want you guys to go ahead and just practice just to make sure you understand how to identify your slope and intercept. Make sure your equations are solved for y first, and go ahead and try these 4, and then whenever you're ready, you can press play and check and see how you did. Okay, so example 1 was pretty straightforward. Your slope was 2, and your y-intercept was 5. The second example, you would have to add 5x so that you're solving for y first. So then your slope becomes +5 and your y-intercept is -3. Example 3 is already in slope-intercept form. I just used commutative property to rewrite it. So then now your slope is that -1 and your y-intercept would be +7. And then example 4, you would have subtracted your x and then divided by 2 so that your slope became -1/2 and your y-intercept was 2. So hopefully that makes sense. It should be pretty easy. Next, we're going to look at slope and intercept in context of a word problem, and then we'll take a look at how they are shown when you see graphs. So it's important to understand slope-intercept form in word problems as well, and we've already done stuff that technically has used slope and y-intercept. We just haven't written it out that way. So we're going to take a look at this one and kind of apply it to now slope-intercept form. So this says every month Stu saves money to put away for college. He starts with $450 in his savings, and then every month he saves $50. Write an equation in slope-intercept form to represent his total savings. So in this problem, since we want total savings, that would be the y variable, which is your output. And your input on the other side of your equation is everything that Stu has. So he starts with $450, and then it says each month he saves 50, so that'd be plus 50x. Now, if I want this to look a little bit more like slope-intercept form, I'm going to go ahead and put 50x first, plus 450. And what this means in terms of this word problem is 50 is your slope, and that's the amount of money that it's constantly increasing by each month. And slope is a rate of change, so 50 is the rate of change for Stu each month. And then his starting point is 450, and that would be your y-intercept, which is stating how much money did he begin with, and we know he began with 450. So we've already seen these, but now this is just kind of understanding how to apply it to your slope-intercept form with equations. All right, so just like finding slope from a graph is pretty easy, I also think writing equations in slope-intercept form when you have the graph is also pretty easy. So you can copy these 3 steps down. Basically, if you're going to write an equation in slope-intercept form, then you need the slope and you need the intercept. So if you already have the graph, you would just find the slope the same way we've done in class. So count your rise over your run. And then you just literally look at your graph and find the y-intercept, and that would be b. And you substitute your slope in for m and your y-intercept in for b into your slope equation, and you're done. So it's pretty basic. It's very easy to do, just counting and looking for a y-intercept. Okay, so we're just going to practice doing this with some of these graphs to just make sure you're comfortable with writing equations in slope-intercept form. So if you look at your first example, first of all, I noticed that I have a positive slope. I'm going to go ahead and write my slope formula out, and then I'm just going to substitute my values in. So I'm going to look for my slope and my y-intercept. So I know they give you some points on this graph, but you can go through and maybe look for some other points. I think I see a good point, and these are actually not the greatest points. So this graph, in my opinion, is not the best graph. Normally you have some better ones. Sometimes it's really hard to get the lines to match up with the graph that you have there. So I believe all of these are pretty good points, which we'll go with that one. So my slope looks like it's going up 1. I'll do it in red, and then forward 2. And you always want to make sure you're looking at the numbers on the scale as well, so that you know that you're counting by ones here. So going up 1 line is going up 1 unit, and then forward 2. And then your y-intercept is where it's cutting through that y-axis, which is at this line right here, and that's the value of 2. So our equation would literally just be y equals your 1/2 slope x plus 2. The second one looks like a negative slope, so I know my answer should be negative. So again, I'm just going to calculate my slope. So I'm going to go up 1, 2, 3, and backwards, which is going to be a negative 1, 2, 3, 4. So negative 3/4 x, and then my y-intercept is right here at positive 3, so plus 3. Okay, your third example, I just want to point out right now, if you look at the graph, you should start to notice this one might be a little different than the other ones. You really have to be careful with these ones, because this is where it will make a difference, and you would get the problem wrong if you're not careful. I'm noticing that every line here is counting by 2s instead of counting by 1s. So as we do our slope and our intercept, we have to consider that every time we jump a line on here, it's actually jumping 2 spaces. So I need my slope first, so I'm going to find some good points. And then as I'm counting my slope, I know this looks like I'm going up 2, but if this is counting by 2s, I'm going from 2 to 6, which is actually rising 4, and then running forward 2 spaces. It's 1 grid space, but again, it's actually 2 units. So my slope is 4 over 2x. And then my y-intercept is the one that would really be incorrect if you did not look at the graph labels and know you're counting by 2s. My y-intercept is at 6, and some people might have put 3. So you want to be careful. And then the only thing we can do to make this a little simpler is that our slope of 4/2 we can just simplify to a slope of 2, or 2 over 1. Example 4, again, so find some good points. One here and here. and then I notice right away that this one is counting by ones again, so I don't have to be as careful. So when I go up 2 spaces, that's just rising 2, and then I go backwards 3 spaces, it's just a run of 3, and it's negative because you're going to the left, and then your y-intercept is right here at your -2. Okay, your last examples would really kind of go back to when we took notes on slopes and we talked about Hoy-Vux. So if I look at example 5, I see that I have a horizontal line, which means it's going to have a slope of 0, which means your equation, and this is what we haven't really seen yet, is going to be y equals something. So if you're kind of stuck, you can still apply your slope, your rise over your run, but what you should notice if you pick some points on that line, it doesn't rise. So if we were thinking of slope as a rise, it would be 0, and the run can be anything because I can pick any points on here and run 1, 2, 3, or 4 spaces, so I'm just going to put 1, x, and then your y-intercept is up here at +3 right here. So if I know that this right here is 0 times x, or just a slope of 0, you basically don't even need that. So we can rewrite this equation as y equals 3, and in Hoy-Vux, that's what the y stands for, that your equation will just be y equals whatever the y-intercept is and where it goes through the y-axis. So for your second one, number 6, I have my vertical line, which I should be thinking is an undefined line, so this one doesn't even make sense. It won't look like any of the other equations we've had. And we've got the undefined slope. And what would happen when I start to go and write my slope out, if I pick points, I can rise any amount, but my run would always be 0. So we know this is an undefined slope. We know this is not a function. So the equation of this actually does not even have an input-output setup. It's just going to be that no matter what, the input would always be the same value, and that value is where it goes through the x-axis, which would be at +4. So no y equals for this kind of equation, because it is a vertical line and it only goes through the it goes through the x-axis, and x is always 4, so we're just proving that x is always 4 by saying x is 4, or x equals 4. Okay, so I know this is the last example on your note sheet, but I have a few things that you guys are going to need to be able to do for class tomorrow. So if you can just take a look at the last little bit of this video, it will help you guys for tomorrow when you're doing your task cards, which will count as a grade.
Thank you. The end has no end. Evil see you soon.